This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape Retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking wind site owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast. Welcome back. I'm Dan Blewett.
I'm Alan Hall.
And I'm Rosemary Barnes.
And this is the Uptime Podcast, bringing you the latest in wind energy tech, news, and policy. All right, welcome back to the Uptime Wind Energy Podcast. I'm your co-host, Dan Blewett. On today's show, number one, we've got two friends of Uptime. We have Frederick Diamond from Greenboats. He's the CEO and founder. And we also have co-managing director from Greenboats, John Paul Shermer. They're going to be joining us to talk about their sustainable natural fiber composites. You know, they've been using them on nacelles, and more of their interesting, innovative composite work is making its way into the wind industry. So we're going to talk to them about what they're doing and some of the innovations and how they've gotten to this point and where they're going. Before that, we'll talk about Shell. They're buying power from the Dogger Bank wind farm. We'll talk about some interesting research done by Ori Catapult about mooring and anchoring systems for offshore wind. After our interview, we'll talk through the UK's plans for a giant battery, which is going to help to manage offshore wind energy. We'll talk about Mingyang's new factory that's looks like it's been approved for the UK. And lastly, we'll talk about a little bit just general employment stuff, which is the idea of the legal right to disconnect and how that can affect employer relationships, mental health, and all that stuff. Which is pretty applicable to this market and many others. So before we get going, be sure to subscribe to Uptime Tech News, which you'll find in the show notes of today's podcast, as well as Rosemary's YouTube channel. And again, she's doing live streams every other week and has tons of new content on the regular about wind energy, renewables, all that great stuff. So be sure to subscribe to both. You'll find them in the show notes below. So first, let's talk about this Dogger Bank wind farm. So Dogger Bank C they've just entered into a 15-year power purchase agreement with Shell, and that's going to be for 240 megawatts in this final phase of the wind farm. So obviously we talked a bunch about fossil fuel companies getting involved with wind energy. Alan, is this just sort of more of the same from Shell, or is this like a new pivot for them, or what should we expect from this power purchase agreement?
Well, Shell's going to continue to expand into renewables, and they've been involved for a long time. I can remember 20 years ago where it seems like they were involved, one of the early ones in the energy sector that was dabbling in renewables. And I don't think that's going to change. I do think that's really fascinating because Shell is under quasi attack on some level, or being aggressively chased by the Netherlands, and that the Netherlands in a court case assigned Shell at fault for carbon emissions, and basically telling them that they have to cut their emissions by 50%. I think it's by 2030. So a relatively short time frame. And Shell's like, I'm sure they're thinking to themselves like, whoa, wait a minute. Like, we're investing in renewables. We're trying to make the transition over. This isn't helping. And in fact, after that ruling happened, Shell is saying goodbye to the Netherlands as their headquarters, because they're kind of the 50% UK, 50% Netherlands company. They're going to move their headquarters to the United Kingdom, and then they're eventually in Dogger Bank, which is off the shores of the United Kingdom. I think more of that will happen. More energy companies are going to be moving around like Shell did or is doing. To get to a place where they can grow and expand into the renewables. It's going to take time and billions of dollars of investment to make the transition over. putting false constraints on it, and I call the Netherlands ruling a false constraint based on the Paris Accords, is not helping them do that. I think Shell felt like it's going to be a financial constraint on them, so they wanted to move. But that hasn't stopped their efforts in renewables in the United States and elsewhere. And I think if you want to bludgeon an energy company, I wouldn't pick Shell as that company. Maybe I'm missing some of the finer detail on this, but worldwide, I think Shell has done at least a decent job on the renewables side. And I don't know, Rosemary, do you see the same thing from Shell on at least being invested into renewables? It's not like Chevron, which refuses to do it.
Yeah, I don't have a big problem with Shell relative to other fossil fuel companies. They're doing more, and I feel that they're actually investing in projects that they think are going to, contribute to the future energy mix, rather than pure greenwashing like I see other companies doing. But on the other hand, I also don't feel sorry for them because all these companies they haven't had the best track record of producing emissions, but also, trying to get in the way of fast movement on climate change. So I'll say, yeah, Shell is definitely amongst the better of the big fossil fuel companies, but I find it hard to feel sorry for them.
No, I don't think you have to feel sorry for them. I think you have to realize that there's a balance, that they're doing a thing for society that society desperately needs, like putting people in sub-zero weather all winter with no heat is a bad thing, and Shell provides an alternative to freezing to death. That's a very positive thing, and people are willing to pay for that. But it does have obviously some opposite consequences. But if it's like an energy company is like a huge moving train, it doesn't stop or change directions quickly, right? Or a big moving ship. You just can't change it on a dime. And I think you have to be able to allow those energy companies to make the motions that they need to make. And if putting artificial barriers in or penalizing them while they're trying to make that transition isn't helping anybody. I think it would, if I was going to impose a penalty on you for, I don't know, whatever, it doesn't make you more energetic to go out and do that thing, right?
I don't know. I think companies, they operate within the laws that are set for them, and they have, a responsibility to maximize shareholder value and all that. And so I think it is the place for governments to make sure that the market is set up to provide the outcomes that we want. If there is no reason, if you're not giving them a reason why they have to, stop putting a lot of CO2 into the atmosphere, if you don't give them a reason why they would have to do that, then they wouldn't, they shouldn't, they can't, according to, rules around their responsibility to their shareholders. So I think it's perfectly reasonable. I mean, the Netherlands can't go after fossil fuel companies that aren't headquartered in their country. So their government has said this is important and done what they can. It's incredibly important to the next generation. So I think overall, it's probably good. If Shell wants to leave the country, then that's a risk that the Netherlands faces, but it's also a risk for Shell as well. It's not so easy to just relocate your headquarters.
So moving on, let's chat about ORI Catapult. They've put out a really extensive PDF with some of their research on mooring and anchor systems for offshore wind. Obviously, they do great work, and they're an innovation leader. Alan, what were some of your takeaways? Obviously, they have lots of diagrams and schematics, and again, tons of their research. It's really well done about just different mooring systems and some of the ideas about. Right now it just seems like there's a lot of different prototypes and different types of floating anchor systems out there. And I don't know, are we going to see one sort of pull ahead of the other? Because it seems like right now there's just lots of different sort of hats in the ring of which design might be best and which mooring system might be best. And I think it seems like everyone's still trying to figure it out, right?
Right. You see different opinions coming from the different manufacturers, and I think that's going to evolve over time. It's going to come down to a very basic design with slight variations. And ORE Catapult, if anybody's not watching ORE Catapult, you should watch ORE Catapult. You should go to their YouTube page and you should see what they're up to, because they're doing really fascinating technology pushes in wave and tidal and wind and offshore wind and robotic fixes for wind turbines and all these areas that are essentially about making the United Kingdom energy independent. And that's cool. And they're doing some of the really good technology work. There's so much technology sitting in the UK around renewables. It's crazy just to sit on the sidelines and watch that go. So the offshore floating wind summary that I saw from ORE Catapult lists the possible variations, and it kind of goes like this: drop some very heavy cables or chains, make them very long, let them drag on the bottom of the ocean, and so the turbine kind of floats along there, and as the turbine bobs up, it actually lifts that cable off or chain off the bottom of the ocean, adds more weight to it, basically sinks it back down. So it's like a self-dampening system. Pretty straightforward. The more intuitive ones are like, let's anchor something to the floor. Let's actually put an anchor down, and it'll grab the ocean floor. So when the turbines pull left and right, that anchor will drag and try to keep it in place, all the way to driving some pilings into the ground and then physically grabbing hold of those with cables, which is kind of what the GE solution was recently. Like they're going to actually pin it to the floor, then have some actuators on the platform that control the amount of pivot that the turbine does. All those are great ideas, but nobody really knows when I put a 25 megawatt turbine on that kind of configuration, what kind of loads I'm going to impose onto the wind turbine. And I think that's where it's all going to come down to, is which turbine wears out because of the floating platform first, and what are you going to do about it if you start to have a problem 3-5 years in? Are you going to try to change the platform? Are you going to try to change the way it's moored? Maybe. And Rosemary, I mean, Australia is a place where there's going to be a lot of offshore wind, and I think your oceans are different than the United Kingdom's. But don't you see those same load issues with floating wind and the platforms?
Yeah, I mean, so Australia is different to Europe, and a lot of the places that are, becoming early adopters of offshore wind it's in places where the seafloor is quite, the ocean depth is quite shallow. And Australia's, the ocean, not the seafloor, drops off quite rapidly. So there isn't a lot of space where you can put in a traditional kind of, like fixed foundation offshore wind turbine. So I think we'll be watching closely for floating developments, because once we figure that all out, then that will unlock a lot more potential for offshore in Australia. And I mean, we've got a lot of coastline here relative to the number of people in the country. So I think that we're quite lucky there. I'm really excited about, like as an engineer, isn't this just like the best part of a new technology, when everyone it's like you've got a difficult problem to solve. There's a bunch of different ways that you could do it and pros and cons for all of them. And then we're at the stage now, like even pretty much just like last year, we started to see people actually installing prototypes. Let's see which ones work the best and what new problems arise that we didn't foresee. I think it's really, really cool. And one of the most fun things that's happening with energy technology at the moment.
All right. Well, we're going to jump now to our interview with Frederick Diamond and John Paul Shermer from Greenboats. All right, guys. Well, thanks so much for joining us on the show. So first, since we have the both of you on here, let's kind of get you introduced so you can, so we can get your voices distinguished here with our listeners. So Friedrich, let's start with you. So you're the founder and CEO. Can you just kind of give us a quick 30-second overview of your kind of day-to-day with Greenboats?
Actually, I started the company in 2013, and I'm a boat builder in profession. So I started the company Greenboats in 2013 I'm a boat builder in profession. I'm a boat building master. My part in the company is the building side, inviting materials, trying out materials, and all this sort of stuff.
So you're pretty much the craftsman, the main guy, hands-on, tinkering, finding the new solutions, and getting everything tested. And
trying different materials, and
And Paul, you're co-managing director, and you're kind of more the big picture guy. Is that right?
Yeah, you can say that. And I have a very, very humble co-worker because he describes himself so modestly. But in the end, I met Friedrich in 2015 for the first time, and I got introduced to what he's doing. So building composite structures out of sustainable materials. And I was just blown away by the potential that this could have. And so after 2017, we started our business together. And my job is really, from the beginning, was to use the know-how and try to find ways how to scale it, and also especially how to find applications outside of marine, outside of sailing boats, which Friedrich was focused on in the beginning.
Yeah, because obviously, as your name entails, I mean, you guys started with boats, but you're really starting to branch out into a lot of other things that we'll get into today. So yeah, that makes a lot of sense to have that sort of duo where Friedrich, you're more the craftsman, and Paul, you're leading the business side of it and getting you guys out there, beyond just boats. So obviously, we want to hear the why behind this, because some of these really big companies aren't really focused on certain aspects of sustainability, or maybe they don't get there until they're pushed, right? But you guys have had a long time of research, and you guys have been developing this stuff for about a decade now. And I guess the question is, the market is now just sort of starting to blossom. So back when you guys started, there wasn't really a strong market for sustainable composites at all. So Friedrich, can you kind of take us through this? I mean, why did you guys start this vision when, it just seems like you're really forward thinking when you guys got rolling. So can you give us kind of the backstory on the company?
After my apprentice, I went in a company where they were just building composite boats, so built from carbon fiber in vacuum infusion or pre-preg and glass fiber boats and stuff like that. And that was for me very, very interesting, because the technique is just like amazing. You're so free in shape. It's so incredible lightweight, and you have such a durable material. And what I just didn't like was the material itself, because from the viewing point of the boat builder, it's all synthetics. It's all itchy on your skin. It's smelly. It's actually quite an ugly material if you don't put a nice layer of white or whatever color paint on top. That was for me the point where I started to think about what could you change on composite building, because if you do it right, it's just an amazing material. And if you really engineer the composites, it's just like awesome. And so I thought about, okay, how can you replace, as example, the glass fiber? Or are they natural fibers that you can work with in the same process and replace with them the glass fiber? And as well for the resin systems and for core materials. Took me quite a while, or I actually started with that while I did my boat building master. Or at the end of my boat building master, I built my first boat from linen fiber instead of glass fiber, cork as a core material, and a natural fiber based epoxy resin system. And that was pretty much the start of green boats, or of the vision to build cleaner boats, and as well for not just for the environment, as well for the boat builder.
So it sounds like you just had kind of a strong connection with nature and these natural materials, and building a wooden boat was, this human experience. And the composites, though they're, they give you a lot of flexibility and freedom for shape, and they're strong and lightweight, but it sounds like just the synthetic nature of them, like you said, the color, the smells, the texture, even the health impacts of the workers, those just didn't really sit well from you. So it sounds like you guys are trying to find that happy balance where you can build freeform and have the same benefits of composite, but still have that connection with natural materials and that sort of earthly, history that boat building has had. Do I have that right?
Yeah, exactly. And if you take the natural materials, it's just something where we can really be proud of.
And Paul, so can you kind of take us from, so you guys started to figure out that this could be done, and then as you joined and started to reach out into the public eye, how did it go from conception to getting your first boat sold and getting to where you are now, really starting to branch out?
Yeah, I think what Friedrich just mentioned, what's really important to acknowledge is what makes Green Boats somewhat different is that the craftsman is really at the center of the company. The craftsman, a lot of innovation is created around the creativity and the instinct of the craftsman. And that's also a bit the story of Friedrich from what he just explained. And in that process, you realize you shift. I mean, but in theory, it has been known already for a long, long time, at least since the 70s, that natural fibers do have interesting mechanical properties, right? But for some reason, this has never been taken into structural applications. At best, these fibers have been used, whatever, in the interior of doors or whatever, for some non-structural applications. Non-woven fibers are used for these applications. And what Friedrich did is he just figured out, hey, how can I combine these two worlds? The possibilities of composites, but the appeal and the aesthetics of classic wooden boat building. And it started from this natural aesthetic point of view, right? For me, what really blew me away was when I figured out that you can effectively substitute almost or virtually all glass fiber applications. Because that's, in the end, I mean, the majority, what is 95, 98% of all applications are glass fiber based, right? There are a few carbon fiber based applications, and they certainly have also their merit. But the grand mass is glass fiber. And then the second point to it, meaning being that this incredible end of life problem, that people are just starting to get their head around. And I mean, Ellen, you made me aware of some of these articles. By 2025, for example, in Europe, there's going to be a ban for landfill of wind turbine blades. I mean, there's so much coming up for us, and natural fibers would be, I'm not saying it's the sole solution to everything in the world, but it certainly offers a whole lot more in terms of options. The easiest way to understand our strategy is to break it down into horizons. And our horizon one was very much about showing what's possible with natural fibers, doing as many crazy projects as possible. So really doing like a nacelle. I mean, you've seen this project, the images, and I'm sure you're going to also make them available for your audience. So just showing it's possible to build a 100 square meter, 300 foot surface structure that's out there offshore out of natural fibers. I mean, if you see that, you have to see it to understand. And the boats, why do we build boats? Boats are subject to wind, to weather, they can't imagine more forces against you. Arguably, it's even more difficult to the life of a boat is arguably more difficult than that of a spaceship, right? Because you have even more salt water, everything against you. And Friedrich, with his talents and with his amazing team, was able to build products which are competing on, we always say, 3 dimensions. So you first compete, of course, on the performance side. Can you build a boat that's sailing nicely, right? Can you build a boat, let's say, with the same properties, but made out of natural materials? Well, that's great. That's what Friedrich did in 2016 with the Green Bente. That was like the first more commercial project. What I've just shown you before the interview downstairs in the workshop, the Flux 27 we're building, that's a boat that's even 15% lighter than a GRP boat, right? So keep that in mind. It's even a better performance than a conventional GRP boat. So we're competitive in terms of cost, we're competitive in terms of performance, and then at the same time, we're building a product which is 80% made of natural or recycled materials. So if you just make like a space defined by these 3 axes, we are certainly in that space. We're defining new spots, in that coordinate system of sustainability, costs, and performance. And that, let's say, is horizon 2, because we can create a viable offer within niche markets. And the next step is for us, of course, to create these viable solutions also in mass markets. And in particular, and that's why we're so happy to be featured in your show. In particular, this of course counts for the wind industry, for wind energy industry, because it's by far the biggest user of glass fiber reinforced composites.
Yeah, and I think that's interesting because lots of companies have started solving one problem and then have grown and just seen, their solution apply to other problems. Alan, which was it in the aerospace engineering? Was it Raytheon that made refrigerators and then they became a missile company?
Yeah.
Was it them?
Well, yeah, a lot of them did. Yeah. Yeah, sure. GE was kind of like that. Raytheon was another. There are multiple stories like that. They started in one industry and ended up in another because they had expertise in a very niche area, and they had the engineers. They could then adapt it to other things. I think this is why Greenboats is so interesting, being in the wind turbine industry and in the aerospace industry. I've seen the use of wood and fabric in the airplane industry. That was the start of aviation. Was all the Wright brothers airplanes are made out of wood and fabric, and that went on for almost 30 years. Just doing that, maybe almost 40 years, where we just made them out of wood and fabric. Even into World War II, there are a lot of wooden airplanes, right, and fabric airplanes. So the application is there. I think what's happened is we sort of got enthralled by other neat technologies, and we've lost all the history with all the natural fibers and we really never really looked at natural resin systems. And so we're learning, right? We're learning, and we're learning in the way that we're trying to understand how these natural fibers work and how consistent they are. That's always the question. Wood, same way. Like, how consistent of structural element is this, and can I buy it in gross mass quantity? And that's why this Greenboats company is so fascinating, really, is because you've done all the heavy lifting, right? You've done the hard part. And I guess from an engineering standpoint, how comparable is natural fibers to fiberglass in terms of strength? Is it close, better, worse, same?
So it's close. It's you can actually compare with the stiffness of the product. If you compare with, like, I don't know, pulling strength or something like that, it's a bit less, but the density is actually the half of a glass fiber, and so you can pretty much match up with a glass fiber, and so
your weight versus strength are comparable.
Yes, exactly.
And that's the key for wind turbine blades, right? It's a question of mass versus strength. That's why we have used some carbon fibers, because it's stronger, but it's a little bit lighter weight. But the vast majority of wind turbine blades are made out of fiberglass because it's a less expensive product to use when you build it. It's not a less expensive product at the end of life. And I think this is where your technology comes into play, is what happens at the end of life? What do we do with this boat, wind turbine, nacelle, once we're done with it after 20 years? Where does it go? And I want to hear a little bit about the technologies on the backside. Why a flax fiber? Why a linseed oil based epoxy system? What's the benefit at the end of life?
So it's actually all about this CO2 footprint of the product. So the flax fiber just grows on the acre and binds CO2. And if you compare that with the glass fiber, you need 5 times as much energy to produce the glass fiber compared with the flax fiber. And pretty much the same with the resin system. So you really save a lot of CO2, and when you perform an LCA analysis, you end up with a reduction of CO2 of 80%. So between 60 and 80% compare of the input material you choose, and so that's pretty much all about. And at the end, it is possible to do a thermal recycling that's pretty much CO2 neutral.
That's a huge reduction.
And can you take us through some of the materials? So I know there's like flax, there's cork. You guys also use recycled PET. But what is going into some of your composites?
So it's all the question: what are we going to build? So we actually, when we have areas where you need like a really good insulation, vibration absorption, sound insulation, and stuff like that, cork is a really interesting core material. If you really want to go more into lightweight applications, for example, our Flex 27 we built with a recycled PET as a core material. That is so one option, or even balsa wood. So what else? We have foam materials that are like 100% bio-based, and for really.
And your resin systems are bio-based too.
The resin systems are bio-based too. So we have different approach. We have like really high bio-based resin systems. They are not 100% bio-based. You still need some petrochemicals to reach. I think the durability compared to a standard epoxy resin system. So we really need systems where we can trust on and where we have like the same durability to a standard resin system. So that is something really important. And we as well have like recyclable resin systems where we work with, and that makes sense. Example, for if you use like fibers like carbon fibers or fibers where you need like a lot of energy for the production. Like for a carbon fiber, you need 10 times as much energy if you compare that with a flex fiber. But some parts, some parts of the composite, you really want to have carbon fiber because they're just so high loaded. So if you build something like that, it is interesting to use a recyclable resin system because then you can get the fiber back.
So Friedrich, there's actually two sort of waste cycles in a composite structure's life. Boat, wind turbine, airplane, doesn't really matter. The manufacturing, there's a lot of excess material that's trimmed off, ground off, the resin's made and not really used. And then at the end of life, so you have these two major issues with the standard composite systems where you have a lot of waste up front and you have a lot of waste at the end. So you're actually not only reducing, providing a renewable product in the shape of a boat or a wind turbine nacelle or other elements, you're actually reducing the amount of things that are ending up in the landfill that could be somewhat hazardous, right? That you can reduce the sort of chemical nature and the amount of energy expended to actually create these things that just end up straight in the landfill because they don't end up on the final product. There's a lot of energy savings, it seems like, on the renewable green energy, green sourcing of products here. So I think that one of the interesting pieces about your company is you're not just thinking about, we're going to make this product out of green materials. Make it out of cork, balsa, flax. Great. But I think most of the engineers don't realize how much you're losing in the engineering cycle at the beginning, in the manufacturing phase, and at the end of life phase. Those are not things that come into the discussion point when we're designing a structure. We just think, I need this structure, I need it to be strong, I need it to do this task. But you don't think about all the extraneous stuff. And most importantly, the people that are down, like grinding on wind turbine blades, that are trying to make it smooth. There's a lot of grinding and particles in the air. You like to make them as safe as you possibly can. And is that another advantage of using these greener resin systems?
If you look on all the like petrochemical or synthetic materials inside, so they are a lot less toxic as well for the worker. It's a great step.
Right. The safety data sheets that you get when you handle resin systems are astoundingly marked with all the hazards that you need to prepare for, and all the face masks and the eye protection, and you don't want to touch your skin, sort of thing. That's a real piece that engineers don't see a lot of. So we'll design it because it's cool, But from the worker standpoint, it may not be the greatest material ever. And in the safety data sheets are always enlightening to us that, if I had to build this part, I'm not sure I would like to go, have my hands in that material every day. That's a problem for me. And it does open up that sort of safety aspect. That it's a true life cycle product, right? You don't want to hurt the humans that are building it. You don't want to hurt the humans that are repairing it. So how do we do that? We need to use basic greener materials that have, the BPA situation that's in Europe, right? It's a big problem, bisphenol A and epoxy systems, that there's toxicity related to that. Taking those things out of service is good, right? But we need to find real alternatives that we can make nacelles out of or boats out of. And I think you've done that, which is amazing. You're right on that really leading edge of the composite technology where we're going. And that's a great place to be.
Yeah. So Paul, where are you guys going with, because you've done a lot of research and tinkering, you've come a long way. Where are you guys going next?
Well, I think it's a very dynamic process. And I think what's important is to kind of acknowledge what are the overarching trends, what are the mega trends that we are trying to surf on, and where do we see maybe the chance to see an inflection point and time it right. That's also an issue. Time the demand and supply correctly. So the two trends in essence are, first, lightweight, right? We are a society that's decarbonizing, so you need a lot more lightweight solutions. And lightweight, by essence, right now, you end up with composites, right? The composites are the dominant solution for that. And people are just starting to realize now, okay, if you can reduce 60 to 80% easily, right, with our current technology of the CO2 footprint of your composite structure. Today, people are like adding up the numbers in the LCA, and they're like, okay, wait. This is interesting. However, we still have a problem. The material, the flex fibers, are more expensive than glass to buy, right? And they're more expensive to process. So that's something you have to keep in mind. And that's where we as Greenboats come in. Because what we are doing is we're trying to create this atmosphere in the company where we say, let's do mistakes. Because if we do mistakes of the future. We figure out the problems other companies are going to face probably 5 or 10 years from now when they start using these materials. So Friedrich can maybe go more in depth about that. But typically we're dealing with a natural produce, right? We talked about already the fact, how do you ensure that it's homogeneous in quality? How do you deal with moisture? There's a list of issues. Let's put it like this. And there's a lot of academic literature about it. None of that is impossible to manage, right? So what we are doing is we are creating these processes, protocols, combination of materials, the properties, that we define that you can reach if you act and you build in accordance with our, with our knowledge and know-how. And then you can actually harvest these results, what we described. And then when we talk about, I don't know, the numbers better, but there is a very, very, and let's come to the second megatrend. So the first one is lightweight, right? And the second megatrend is sustainability. And in Germany alone, if I trust the numbers, we have to build 2,000 windmills a year until 2045 if we want to source all that green energy, right? And want to live up to our ambitious plans. Year to date, we've built 300. So we are this year down 1,700 units. So next year, it's going to be almost 4,000 units we have to build to keep up with that. Just assume the average, assume like 100 square meters per nacelle. Already, if you add that up, you get quite a big amount of CO2. So it is becoming real. But again, 5 years ago, it would have not been a topic. Now it is, because the price of CO2, it is becoming relevant. In the end of the day, all these companies have to report their CO2. They have to perform life cycle assessments for what they're doing. And for us as a company, we are there and we can help companies in that transition. We can take them by the hand and say, look, we can sit down even with your accountant. That's the person probably you're talking to, to figure out what would that mean for your production over the next years in terms of CO2 savings based on our current technology. And as you can imagine, we're just getting started. We're every day working on new resin systems with even higher biocontents. We are figuring out ways. We're working directly with the source, directly with the people in France at the harvest the linen and turn it into the flex rowings. We're working together with these guys to come up with products that are exactly tailored to the demand of the processor in the wind industry, right? And this kind of knowledge, 5 years ago, people would have been like, why would I use a material that's more expensive to buy and to process? But again, that's what I mean with dynamic, right? Like it's really, we have to get that wave But if we would have started, let's say 3 years ago, we would be bankrupt now. So let's hope that this time, we manage to keep the hustle up and team up with more and more and bigger players. And for, let's say, the last year was crazy for us. I mean, literally, a lot of people that I don't know, more viewed us like as crazy people or artists or something, they're starting to realize, okay, hey, maybe what these guys are doing actually does make sense. And it's going to give me a competitive edge in the long run for my company, for my business. So that's a nice feeling, of course. So
let's talk about the NFC nacelle you did. How did that project come about? And, what were people saying about it once it got out there into the press? Yeah, we are now amazing. I mean, we had a briefing to the audience maybe 2 weeks ago or something. We had a small talk, to prepare for today. And in the meantime, already we've been again in touch with different, not like the end player, if you want so, but let's say agents within the industry, that are really like, okay, now that I've seen the product, I get it. Like I've heard, of course, about natural fibers before, all that stuff. And that's really like a common theme we often have also with our boats. You have to see it. You have to understand that this is not like a fourth grader, whatever kindergarten kid that makes paper mache or something. These are really products that can perform and that live up to all the GNV, whatever regulation standards required. And as Friedrich said, we can reach the standards of a glass fiber product. And so people are really like, Horizon 1 accomplished, like get people excited, make them aware that it's possible, get them excited. Now we have to move these people into Horizon 2. And of course, as of today, I could go with the camera to the left, you see our workshop, we can't build these 2,000 windmills in our current capacity, for sure not, right? But to team up with people who have the resources, and who have the ability with the operations, the delta, to gain, and then we are talking also about a product. We have to stop talking about the sticker price of a product. Because, of course, an NFC nacelle could be more expensive than a glass fiber nacelle. But what you have to look at, what is your lifetime cost of the product? What does it cost you in 20 years, 30 years to recycle it? And so that's what the important thing is, right? We have to compare the lifetime cost of a GRP product with the lifetime cost of an NFC product. And I think we're getting there. I think within, especially if we keep having government incentives and bottom-up pressure from the consumer, we're really getting to that sweet spot where people very rapidly will have to want to change. And it would be short-sighted to say, well, this is too expensive, so this idea doesn't make sense. Because, every new idea is more expensive at first, right? And like you said, as bigger players come on and say, hey, we like this will make sense in the future. Here's some investment money. Here's more resources. Now you can pump them out at scale and then the cost goes down. Is that kind of where you see it going?
For us, the best thing that could happen would be like a steady demand from a client, who has a going concern and who's growing with us. And if we would have, we hope we're getting there. That's also the good thing by not only delivering to one industry, we're also already supplying the caravan industry and transport vehicles and boats, and we may have a panel business unit where we create standardized panel goods. And I think that's a way to go, to really start that's kind of our job as a company, is to make it easier to adopt these materials. And that can be, for example, in the form of semi-finished good. It can also be, of course, in the form of some consulting, of course, always depending on who our counterparty is, and if we are able to have a long-term vision together.
Well, I think a lot of people in wind are just talking about blades, right? Making blades cheaper, making them bigger, making them stronger. But there's a lot of components like the nacelle that, if converted to natural fibers, more recyclable materials in general, are going to make a really big difference when there's thousands more turbines, in the landscape on this planet. Even if it's just a little thing like you talked about door hatches. You guys aren't opposed to starting small where it's like, hey, if this is one little piece or 5 little pieces or here and there, that's still better than nothing. And that's still slowly getting all of us to that goal of a more sustainable future. Is that right?
Absolutely. But also when it comes to blades, not to say too much, but we're in loose talks to build 12, 13 meter blade. So that's certainly, when you look at the rough whatever the requirements from engineering perspective that we know, looking at our material properties, we would be able to reach and we would be confident about. And then again, how would you start? You first build a prototype, show that to the world, and I think the world would go crazy, right? If they see a natural fiber reinforced wind turbine blade, that would really be an eye opener for the whole industry. And mark our words, we are confident that we can do it. It would not. I think it's probably harder to build the Flex 27 day setter that you see down there than a rotor blade. Because in the end, we're talking about a 300 kilo structure roughly for the rotor blade, right? And that's like almost like our hull weight of the boat. And also our boat is 8-9 meter. So it would not be crazy. It's not, that was more crazy what Friedrich did 10 years ago when he built his first products, out of Jute bags. That was crazy.
Well, and it wouldn't have to be, a full blade built completely out of NFC, right? I mean, we were just talking in our previous episode about balsa and how, there's some deforestation of the rainforest associated with balsa. Obviously, there's a lot of balsa farms as well, so not all of it is damaging to the rainforest. But as they're looking to maybe replace balsa, maybe there's another natural alternative for it, or there's another piece in a wind turbine blade that's not structural in the huge sense.
This is our biofoam. So this is 100% vegetable based foam, for example.
Wow.
This is what we're using,
and that could be a core material or something.
This is the recycled PET Friedrich was talking about earlier.
Yeah.
So this is quite standard. This is something we started using 3-4 years ago. I think we're quite pioneering also in that applications. But it's an amazing success story. Everybody's literally using it now. It's actually more expensive to buy recycled PET than virgin PET, I've been told.
Yeah.
Well, whales don't love eating it, from what I've heard. So it's good to get it out of the ocean and into something more usable. As we wrap up here, where are you guys going and what can we kind of expect to see from you maybe in the next year or two?
I really want to, Friedrich, I think you're with me on that one, right? Like we definitely want to build a rotor blade around 12, 30 meters, something within that. We want to build amazing partnerships within the industry. Again, like we are smart enough to know that we don't know everything. Actually, we also are aware that we know actually quite little, but that little we know could be crucial to some of these really groundbreaking projects. And so we would love to partner up with people in this wind power industry.
Yeah, that makes a lot of sense. So, Paul, where can people follow up with you and your work with Greenboats?
I think our most active channel is LinkedIn. We really try to also really have an open style of communication, really openly talk about challenges and opportunities associated with sustainable composites. So and also Friedrich and I, we are open to chat and everything. So that's, I think, the best idea. If you want to do some self-reading, of course, visit our homepage and just Google Greenboats. We actually have good hits on Greenboats. So,
all right. Well, guys, we really appreciate your time and great conversation. We appreciate what you're doing for the industry, and obviously sustainability is on everyone's mind. So it's a really interesting topic, and we appreciate you. So thanks so much for coming on the show.
Thanks for having us.
Yeah, also from my side, Alan, Dan, thanks so much. And really, amazing that you share our message a bit with your community and really appreciate it.
All right. Well, we want to thank again our guests from Greenboats. Definitely check out the links in the description, as always, where you can follow up with them. Definitely follow their LinkedIn page, their YouTube page, all that. They're putting out a lot of great content. You can see exactly what they're working on, and they make some really beautiful boats. They have a lot of really interesting prototypes. So definitely check out Greenboats. You'll find the links to them in the description below. So moving on, UK, they are planning a giant battery to help with their offshore electricity. So obviously this project is 360 megawatts. It's going to be installed in, Rosemary, you want to help me with the pronunciation here? Teesside?
I won't help you with that. I don't have a suggestion, actually. Sorry.
You're just going to let me hang out to dry? You're not even going to try and maybe fail? This is shameful.
I've got a hilarious joke planned in my head, and I'm just waiting for you to stop talking so that I can say my hilarious joke.
All right, fine. Just lurk in the background with your pronunciation joke or whatever is coming. But this big battery project is on its way. Alan, I'll kick this to you first. Are we going to see more of these? And is this a significant first step for the UK?
It is, and I think you're going to see a lot more of it. Teesside's, if it's pronounced Teesside, Rosemary, go ahead. Hit me with the pronunciation of Teesside. Are we pronouncing it correctly? I assume that we are. We are English.
Do I need to cue you
Americans.
for your joke? What's happening? What's
Yeah.
happening?
There seems to be some pent up anger here. Come on.
I don't know, Teesside. It's English, right? We all speak English. Why would I have a special insight here?
I've been less sure than I've ever been if I speak English since joining this show. A lot of words I can't pronounce.
I believe that offshore, for the amount of power they're going to produce, if they're smart and they're trying to maximize profits, that if you can get a battery in the mix, you're going to be able to help you maximize profits because you're going to be selling energy when the energy prices are high. And it's not just the production of power, it's also when you're producing it. And if you're playing a moving energy market like we all are, selling it high and creating it when it's low is the best way to go about that. So if you have extra power, you want to maximize it. And if you can make the economics work, I think there's going to be a lot more of it. And because the United Kingdom is really moving to a much faster than I think a lot of other countries to a renewable, lower CO2 world, that they're going to be leading in a lot of different ways. And I think batteries may be the one place where the UK is really going to start pushing hard to match the Teslas of the world. So this is going to be fascinating, and I hope that they're successful, because what they are able to do on a smaller scale, and the UK is not a huge place like the United States, but what they can do on a small scale can be scaled up and done in other places. And the UK will be in a big advantage because they'll be the leader in that technology, and they'll own probably a lot of patents in that area. And us in America will start writing checks to England to pay for the patent, or Scotland to pay for the patent. And that's a huge income source. I think that's awesome, right? If you're clear thinking and you're mobile like the UK is right now, they can maximize a lot of things, and hopefully they can get the offshore battery technology rolling. Rosemary, do you see a similar thing?
Yes, and I want to make my joke, which is a Crocodile Dundee joke. You keep on talking about this giant battery at 100 megawatts. That's not a giant battery. Australia's got giant batteries. We've already got, I think, more than half a gigawatt of big batteries. There's the famous Tesla big battery that was started by Australia's favorite benevolent billionaire, Mike Cannon-Brookes, tweeting Elon Musk, and we got the world's first big battery in South Australia, and they've been using that for years now. There's a new one in Victoria, 300 megawatts, that was just commissioned recently. That was interesting because they had a fire in commissioning, actually, and it seemed like this was terrible news for the renewables industry. But I think only two of the cells out of 100 were actually affected, and so it was kind of something I've experienced a lot in my career, where you have in mind the worst thing that can happen, which is often a fire, and it feels worse when it hasn't happened than after it's happened and you've seen the worst case scenario, and it's like, oh, hey, we had a fire and it contained and we still completed the project on time. It can kind of feel actually better afterwards that this bad thing happened and it's, things still functioned. Yeah, so just between those two, that's half a gigawatt, and I'm just looking at there's so many planned now. There's one in construction in the Canberra region where I am, 100 megawatts underway, and a bigger one even planned.
What do you think the chemistry is going to be here? It wasn't mentioned in this article about this one, but are we looking at iron air or like an electrolyte battery? I mean, at this scale, what do you think it's going to be?
If they don't say it's lithium ion, that's
right.
Still just grabbing most of the market. And it will stay that way unless and until we start to see a supply squeeze, because everyone wants lithium ion batteries for absolutely everything. So, yeah, unless the price goes up because of that, we'll continue to see it.
We keep hearing about, things like iron air. I mean, when are these going to start? These seem like utility scale, right? These bigger electrolyte batteries that are not very portable, that are very heavy, and obviously have electrolytes literally sloshing around potentially. Why aren't we seeing some projects crop up with those?
They're still in development, and at unless I was just looking the other day actually at some future projections for battery technologies, depending on how much duration that you need and how many cycles you need to do per year, and looking at which type of battery technology was the best. And currently for like pretty pumped hydro has a lot of the applications have pumped hydro as the least cost currently. And then lithium ion kind of has a short duration, kind of a small zone of the chart. And then as you move into the future, lithium ion just grows and grows and grows until it fills everything except for the longest duration, which is going to be possibly hydrogen, possibly a bit of compressed air, and then, hydro as well. But this modeling doesn't take into account the fact that if lithium ion really is used in all these applications, then we're going to run out because we don't have enough lithium mines that are going to be ready to produce 100 times what we're currently using in a few years. So I think that the reason why we don't have so many other technologies now is because for now lithium ion is just the best, and we need to wait for it to get more expensive before we see the other technologies really compete.
Yeah. So moving on, Alan, I'm going to kick this to you. So obviously you've had strong opinions about the Chinese entry into global markets, but Ming Yang has signed a memorandum of understanding to get a UK blade manufacturing and turbine assembly plant stood up in the UK. So Alan, what's your take on this? I feel like this has been right in your alley about concerns you've had globally.
It plays into sort of the greater economic battle that's going on between the United States and China. And the UK has, oddly enough, signed an agreement with China, because when you sign on to a large manufacturer in China, you're signing off with the Chinese government, that those two go together. And the weird fallout of that is like GE is talking about pulling out of a factory in Teesside. So GE is getting a little more hesitant about building a factory in Teesside because they see the possibility of really not winning many contracts in the United Kingdom. So you have to play both sides of this. If you're going to bring in a super low cost provider, then companies like GE can't compete on that playing field and will go away. So you're left with this connection to China. And I'm not sure that's the smartest move for the United Kingdom because power is electricity is a geopolitical pawn in this equation. You can't, you got to be careful. I think you really have to be careful, especially now with COVID. And there's a lot of things with China that are happening right now that I'm not sure you want to promote. As you've seen, Australia, Canada, and the United States are not sending ambassadors to the Olympics in China. That's just a precipice of more to come. And I'm surprised that European countries are actually sending ambassadors to China for those Olympics because of the Uyghur situation, some other things that are happening in China. So seeing that entry into the UK is going to be very worrisome for a lot of wind turbine OEMs because they know they really can't compete financially. And maybe it's a leverage point for the UK government to drive down prices for all the manufacturers, and maybe they will pick a Siemens or a Vestas or a GE eventually, but it doesn't feel like that. And I think that's what makes the United States a little uneasy about what's happening there.
So last on the docket today, I want to chat a little bit about the legal right to disconnect, which is becoming law around the world in various places. In 2017, France introduced some regulations that just created boundaries about remote workers at the beginning and the end of their day. At some other countries, this is starting to become a bigger push. And it looks like it might become eventually law in Europe. And Alan, I'll throw this to you first. Do you see this becoming something in the US? Obviously, it seems like in the United States, we have the craziest work schedule, the least work-life balance at times. Would you see this, like employers backing this? where they have to, by regulations and penalties, cut off contact with employees after a certain time of night?
No. And I think the biggest players that would be against it are the Googles and the Facebooks and the Silicon Valley companies that can push the envelope, I think, a little bit in terms of if you're typing on a computer, writing code, that needs to be available most of the time. So I think they would be very against it. And that'll have an influence on whether it happens in the United States or not. Whether it's a good idea, I think there should be reasonable limits on both sides, from the employee side and from the management side. Putting limits on it, I think, is a little more difficult in the United States. I just don't think there's going to be a real meeting of the minds. The real issue I think is happening in America, which is going to open this up, is Google just announced that if you don't get vaccinated to the level they think is acceptable, you're going to be fired, straight up fired. And they have about 150,000 employees. Okay. For most people, it may not be a big deal, but say for 10% of their workforce, it is a big deal. That will come with a pushback, right? So if you can make me do a health thing, maybe I'm going to push back and say I'm not going to pick up my phone after 5 o'clock. That would be a logical outcome of that there's a little bit of give and take. If I can demand things of you health wise, then I'm not talking to you on Saturday and Sunday. That's the kind of situation you're going to get yourself into, because there's such weird animosity at a high level between employees and employers right now. This is that time when limitations are going to be put on work. I'm not sure it's great for productivity, but I think it's a possibility here in the States right now. Rosemary, do you see the same thing, that worker angst is probably at an all-time high?
I mean, there's maybe similar debate for working hours. And in some countries in Europe, it's mandated you can't work more than 35 or 37 hours in a week. And I mean, Denmark is known for its amazing work-life balance, but there was certainly no shortage of long hours worked. And I had plenty of 60, 80, 100-hour weeks, especially when I was working in the factories, which work on a 24/7 sort of shift. So I think even when there are regulations around that sort of thing, certain jobs you're always going to go outside that. If you've got an important deadline and a worker feels some sort of commitment to a goal, they're going to want to go outside that. And if it's regulated, in some ways it can kind of push you into not keeping track of it at all, because it's like, okay, officially you can't work more than 35 hours. So you didn't work more than 35 hours. Whereas before you might have used to keep track of it on a spreadsheet and, you worked 50 hours the last 3 weeks, so you can have, half a week off now. So yeah, I don't think it's simple, and I don't think that regulation is a simple solution to it, but I do definitely encourage everybody to maintain the boundaries that work for them, because I think you do better at work when your brain actually, stops working sometimes. It's not healthy and not good for your projects that you're there all the time. So I think the goal's good, but it's hard to know exactly the best way to implement it.
All right, well, that's going to do it for this week's episode of the Uptime Wind Energy Podcast. Thanks again to our guests from Greenboats. Be sure to check them out in the show notes and description below. Be sure to subscribe to the show, share with a friend, and we will see you here next week on Uptime. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.